We looked at graphs of exponential functions last time. One of the things about exponential functions that we saw is that every exponential function is 1 to 1, meaning that if an exponential function is equal to something that can be written with the same base, then if the bases are equal and the functions are and the y values are equal, the x values have to be equal. So let me show you an example here from number 16, 2 to the 1 plus 2x with 1 plus 2x of the exponent equals 32. If I can write 32 with a base of 2, which I can, it's 2 to the 5th power, then the inputs have to be equal. 1 plus 2x equals 5, and then I can solve from there. 2x equals 4, and x equals 2. It's called the one-to-one property. I haven't done anything with inverse functions here yet because we don't know what the inverse of an exponential function is yet. That'll be in the next set of worksheet problems that we do when we talk about logarithms. So for our next problem, 15 to the x is equal to 1. Well, anything to the 0 power is 1. So I'll write that as 15 to the 0 power, and then x is going to be 0. 5 to the negative x is equal to 1 over 625. So 5 to the negative x is equal to 5 to the negative 4th. Negative x is equal to negative 4. And x is equal to 4. 4 to the 7 minus 3x is equal to 1 over 16. 4 to the 7 minus 3x is equal to 4 to the negative 2nd. 7 minus 3x is equal to a negative 2. Subtract 7 from both sides. Negative 3x is equal to a negative 9, and x is equal to a positive 3. 5 to the x is equal to 1 over 125. 5 to the x is equal to 5 to the negative 3rd. So x is equal to negative 3. You see that it's really important to know some of your perfect squares, perfect cubes, even some perfect fourths and things like that to be able to quickly realize what power something is here. If you don't recognize it right away and need to use a factor tree, for instance, I would see that 125 is divisible by 5 because it ends in 5. 5 goes into 125 25 times, and 25 is 5 times 5. And then I could say, oh, well, that means that this is 5 to the 3rd power. Four to the x is equal to 16. 4 to the x is equal to 4 squared. X is equal to 2. 2 to the 3x minus 7 is equal to 4. 2 to the 3x minus 7 is equal to 2 squared. 3x minus 7 is equal to 2. Add 7 to both sides. 3x is equal to 9, and x is equal to 3. 1/4 raised to the x is equal to 64. So that's 4 to the negative 1st raised to the x is equal to 4 to the 3rd. 4 to the negative x is equal to 4 to the 3rd. So negative x is equal to 3, and x is equal to a negative 3. 5 over 4 raised to the x is equal to 16 over 25. Okay, I don't see a power of 5 in the numerator. I see a power of 5 in the denominator. So I want to take the reciprocal and make that the opposite exponent. And I see 4 over 5 squared, because this is 4 squared and 5 squared. So negative x equals 2, x equals negative 2. 5 to the negative x equals 1 over 25. 5 to the negative x equals 5 to the negative second. Negative x is equal to a negative 2, and x is equal to 2. 2 to the x squared minus 3 equals 64. So x squared minus 3, 2 to the x squared minus 3 equals 2 to the 6th power. X squared minus 3 is equal to 6. X squared is equal to 9. X is equal to a negative 3, or x is equal to 3. Both answers should work. 9 to the 2x times 27 to the 3 minus x equals 1/9. So I'm gonna make everything base 3 here. This is 3 squared to the 2x times 3 to the third raised to the 3 minus x equals 3 to the negative second. So this is 3 to the 4x times 3 to the 3 times 3 is 9 minus 3x is equal to 3 to the negative second. When I multiply like bases, I add the exponents. This is not, sorry. Three to the 9 plus x is equal to 3 to the negative second. 9 plus x equals a negative 2. X equals a negative 11. $625 raised to the x is equal to 3125. I can't see anything with 3125 off the top of my head, so I'm going to factor. I know that this is 5 to the 4th, so I'm going to assume that this is 5 to some power. Oh, that's going to be 5 to the 5th. I see that now, just because it's 5 times more than this. So this is 5 to the 4x is equal to 5 to the 5th. 4x is equal to 5, and x is equal to 5 over 4. Two to the 11 minus 3x is equal to 4. 2 to the 11 minus 3x is equal to 2 squared. 11 minus 3x is equal to 2. 3x is equal to 9, and x is equal to 3. Watch out with this one. 8 to the 2x minus 1 equals 16 to the 2x. 8 is not a power of 16. 16 is not a power of 8, but they're both powers of 2. So we're going to write it with a common base of 2. 2 to the 6x minus 3 is equal to 2 to the 8x. 6x minus 3 equals 8x. Subtract 6x from both sides. X equals negative 3/2. 4 to the x minus 1 equals 64 to the 2x. 4 to the x minus 1 equals 4 to the third. Base 2x. 4 to the x minus 1 equals 4 to the 6x. X minus 1 equals 6x. 5x equals a negative 1. X equals a negative 1/5. We're on number 32 now. 125 over 27 raised to the x plus 1 equals 3/5 to the x minus 1. This is going to be 5 to the third over 3 to the third. It's going to be 5 over 3 to the third times x plus 1. When I raise a power to a power, I multiply. But I don't want 5/3, I want 3/5. I'm going to make this a negative 3. And that makes this negative 3x minus 3 equals x minus 1. Let's subtract x from both sides. Add 3 to both sides. Negative 4x is equal to 2. Divide by negative 4. X is equal to a negative 1/2. That was 32. Now let's look at 33. 1/3 to the 4x plus 2 equals 9 to the x minus 1. This is 3 to the negative first raised to the 4x plus 2 equals 3 to the second raised to the x minus 1. 3 to the negative 4x minus 2 is equal 3 to the 2x minus 2. So negative 4x minus 2 is equal to 2x minus 2. Subtract 2x, subtract 2x, add 2, add 2. Negative 6x is equal to 0, and x is equal to 0. E to the x raised to the x times e to the 16th is equal to e to the 10x. So this is e to the x squared. So e to the 16th is equal to e to the 10x. E to the x squared plus 16 equals e to the 10x. So x squared plus 16 equals 10x. X squared minus 10x plus 16 is equal to 0. X minus 2, x minus 8 equals 0. X minus 2 equals 0. or x minus 8 equals 0, x equals 2, or x equals 8. And both of those work. E to the 5x minus 1 equals e to the 4th raised to the negative x. So e to the 5x minus 1 equals e to the negative 4x. 5x minus 1 equals a negative 4x. 9x equals 1, and x is equal to 1/9. We're going to finish up with number 36 here. E to the x minus 6 is equal to 1 over e to the 5th raised to the x plus 4. This is going to be e to the x minus 6, e to the negative 5th raised to the x plus 4, e to the x minus 6 equals e to the negative 5x minus 20. X minus 6 equals negative 5x minus 20. Add 5x to both sides. Add 6 to both sides. 6x is equal to negative 14. X is equal to negative 7 over 3. That's it for this video. Exponential functions are important for exponential growth and decay application problems. So I'm going to come back and talk about those when I get into the quantitative reasoning stuff, because I have more worksheets on it than I do here for pre-calculus. So just know, though, there's a couple example problems down here I'll let you look at before I leave, where one of the problems that we have is compound interest, and we get continuously compounding interest is another type of exponential growth where interest is calculated at every instant in time. So we'll talk about both of those in our quantitative reasoning material when we get to that. It's just hang on, this idea comes back in some other classes and is very useful in sciences and economics, and all kinds of things follow these exponential growth and decay models. All right, see you for the next video when we talk about logarithms.